Here we go with our probability solutions. The probability that Pedro scores a goal in any match is 2/5. We want to calculate the probability he scores a goal in each of his next 2 matches. Remember, there are 2 ways to combine probabilities. If we want both things to happen, then we multiply our probabilities. If we're okay with either or of our things happening, we add our probabilities. So, he wants to score a goal in each of the next 2 matches, in both matches. So 2/5 for match 1 times 2/5 for match 2. We combine the probability with multiplication because we want both those things to happen. That's going to come out as 4/25, and that is fine for our answer. Ravi spins a biased 5-sided spinner numbered 1 to 5, and the probability of each number is shown in the table. Remember, these probabilities have to add up to 1. Now, because these are both shown as x, we know they're both the same. So I'm essentially solving a nice easy equation here. 2x is equal to 1 minus all these other probabilities. So you can just type this into your calculator and solve for x. I'll do that now. 1 minus a sixth minus a quarter minus a third gives me 1/4, so if I divide that by 2, x will equal 1/8. If he spins the spinner once, we want to find the probability the number he lands on is a 2 or a 3. Well, for or, we add our probabilities. So I do 1/4 add 1/3. This comes out as 7/12. Ravi spins a spinner twice and wants to find the probability it's a 2 both times. So I take the first 2 being 1/4 and the second 2 being 1/4 and multiply them together, because multiplication is what we do if we want both things to happen. Now we want the probability, if he spins the spinner twice, that the sum of the numbers is 3. Now this one can only happen one way really, a 1 and a 2. But we have to be careful. We could get a 1 and then a 2, or we could get a 2 and then a 1. So the probability of a 1 and then a 2, we want the sixth for the 1 and the quarter for the 2, and both those things need to happen. So we multiply them together. That's 1/24. But of course it could happen the other way as well. A quarter times a sixth. That would also give me a 24. And the sum of the numbers being 3 could happen if this or this happens. So we have to add them together. And if we add them together, our result becomes 1/12. So always pay attention to all the different ways in which the situation can come about when you're doing probability questions. Now, he spins the spinner 72 times, and we want to calculate how many times he expects the number 1. Now, whenever we talk about probability, we're saying what the chances are of something happening of all the times that we do it. So the number 1 has a probability of a sixth, which means it's going to happen 1/6 of the time. This is a really important thing to remember. This of the time statement is always hiding behind the word probability. We expect a number 1 1/6 of the time. 1/6 of 72 is 1/6 times 72, and we can do that on the calculator. He's going to expect it to happen 12 times. Haroon has 15 parcels to post, and the table shows information about the sizes of these parcels. 2 parcels are selected at random, and I want to find the probability that both parcels are large. Now think about this situation. Let's select them one at a time. Whenever we're doing things in probability, we don't worry about them happening together. We think about them happening one at a time. So the probability that both parcels are large means the first one we grab is large. There is a 6 out of 15 chance of getting a large parcel. But then if we go back again, there are only 5 large parcels left out of 14 altogether. And if both parcels are large, we need to multiply these probabilities together. So, if we do that, that's 6 times 5 on the top, divided by 15 times 14 on the bottom, and that's all coming out as 1/7. One parcel is small and the other is large. Now once again, don't get caught out. There's more than one way this can happen. In fact, it might be a good idea to draw a tree diagram here. So we've got a small parcel or a large parcel, followed by another small or large, or small or large. To get one small and one large, we could go this way, or we could go this way. And we have to consider both of them if we're going to get the whole answer. Let's put some probabilities down. Probability of a small parcel being picked first is 9 out of 15, and a large parcel being picked first is 6 out of 15. But then there are only 14 parcels left. Over here, for instance, there will be only 8 small parcels out of 14, and there will be 6 large parcels out of 14. But if I'd picked a large one first, I would still have 9 out of 14 on this branch. There we go, 9 out of 14, and 5 out of 14 down here. So I want to do 9 out of 15 going for a small parcel, followed by 6 out of 14 going for a large parcel. That's one way of achieving this condition. If I add to that the other way of doing it, 6 out of 15 times 9 out of 14, this is the probability of going small then large, and then going large then small. We times all those together and do the adding, and we get our final answer. So I'm going to quickly do that on my calculator now. So 9 times 6 on the top of the first fraction, 15 times 14 on the bottom of that fraction. Add to the next possibility, 6 times 9, which you will notice is the same thing in this case, over 15 times 14, and altogether I'm getting 18 out of 35. You can leave your answers as fractions unless they specify otherwise, and that's the end of that bit. The probability that a parcel arrives late is 3 out of 80, and 4,000 parcels are posted. We want to estimate how many are expected to arrive late. Well, we expect a parcel to arrive late 3/80ths of the time. 3/80ths of those 4,000 times. So I times those together. And I would therefore expect 150 parcels to arrive late. And I shall do more answers on the next video.